Hello dear students, in this video we will work on the application of quadratic formula to find the roots of a quadratic equation. As we know that the standard or general form of a quadratic equation is ax square plus bx plus c equals to 0, where a is not equals to 0. That is, the coefficient of x square cannot be 0, whereas the coefficient of x and the constant term, that is b and c, can be 0 for a quadratic equation, but the coefficient of x square, that is a, can never be 0. Here we have represented the quadratic equation in terms of x. We have used the variable as x. Remember, there can be some other variable as well. Now, since the degree of quadratic equation is equals to 2, the highest power is 2 of the variable, so it suggests that it will have two zeros or roots. That is, the quadratic equation will have two zeros or roots. Now, zeros or roots are those values of the variable that equates the given quadratic equation to 0. So, the values of x that makes the whole quadratic equation equate to 0, those values of x are known as the zeros or roots of the quadratic equation. The nature of roots can be determined by a polynomial function of its components, which is known as the discriminant. The value for discriminant determines the nature of the roots for a quadratic equation. The formula for discriminant is d equals to b square minus 4ac. b square, that is the square of the coefficient of x, minus 4 times the coefficient of x square a into the constant term c. There can be three different cases, and the first one is if d is greater than 0. That is, if d turns out to be a positive quantity, then there will be two distinct real roots for a quadratic equation. This means there will be two different values of the variable for which the quadratic equation will equate to 0. Since we have considered the quadratic equation to be in terms of x, so geometrically we can represent this particular situation like this. So the quadratic equation, which was in terms of x, the curve for it is intersecting the x-axis in a Cartesian plane at two different points, a and a dash. Now, this is only meant for sample representation, so we can have different types of curves for different quadratic equations. Next situation, if d is equals to 0, in this case we will have two equal real roots for the quadratic equation. So we need to remember, whenever there are two equal roots for a quadratic equation, then the value of discriminant is equal to 0. In this case, we can represent the situation geometrically like this. So here we have only one intersection in the x-axis, that is point A. So that means both the values of the variable will be the same. So both the zeros are equal. The values of the variable are the same. Finally, the third case, when d is less than 0. That is, if d turns out to be a negative quantity. So in this case, there will be no real root for a quadratic equation. That means the value of the variable will not belong to the set of the real numbers and will belong to a different set of numbers known as complex numbers, which are in the form of a plus ib, where I is an imaginary unit. And you need to remember that I is equals to under root of minus 1. So whenever we get negative integer inside a square root, we need to remember that it will be a complex number. About complex number, you learn in the next class, that is in class 11 in higher mathematics. So for the time being, you just need to remember that if d is greater or equals to 0, then there exists real roots and we need to solve them only. You don't need to solve complex roots for the time being. Now let's frame the quadratic formula. So our standard form is this one, and we have already seen that discriminant d is equals to b square minus 4ac. So the formula to find the two values of x or the variable is x is equals to minus v plus minus under root b square minus 4ac by 2a. So this plus minus indicates that we need to consider two different cases, one with plus sign and the other with minus sign. Since the quantity inside the square root resembles discriminant, it's exactly the discriminant, so we can write the same formula as x equals to minus b plus minus under root d by 2a. Remember, there's a special case in this one, that is when discriminant or d is equals to 0, there exist two equal roots. So we can write the shortcut formula as x equals to minus b by 2a and minus b by 2a. So both the roots will be equal as the value of d is 0. Now let's solve some questions. The first one is 2x square minus 7x plus 3 equals to 0. Here the coefficient of x square a is equals to 2. The coefficient of x b is equals to minus 7 and the constant term is 3. So first and foremost we'll find discriminant. D is equals to b square minus 4ac. So d equals to, putting the values, b square, that is minus 7 square minus 4 into the value of a is 2 into the value of c is 3. Now equating, d equals to minus into minus plus, 7 sevens are 49 minus 4 twos are 8, 8 threes will be 24. So d equals to 49 minus 24 will be 25. Since 25 is greater than 0, a positive quantity, so this indicates there will be two distinct real roots for the quadratic equation. Now using the quadratic formula, x equals to minus b plus minus under root d by 2a. Now let's put the values. X equals to minus, the value of b is minus 7, so within brackets minus 7 plus minus under root 25, the value of d, by 2a, 2 into 2. X equals to minus into minus plus, so the sign will change to plus 7 plus minus 25 can be factorized as 5 into 5, so under root 5 into 5. Next, x equals to 7 plus minus 5. We are taking 1 5 out of the square root. Now we have two different cases where we need to take plus 5 and minus 5. So x equals to 7 plus 5 by 4 or x equals to 7 minus 5 by 4. So we need to consider plus 5 as well as minus 5. So that gives us the two required roots for the quadratic equation. X equals to 7 plus 5 will be 12 by 4 or x equals to 7 minus 5 will be 2 by 4. 4 ones are 4, 4 threes are 12 or 2 ones are 2, 2 twos are 4. So the values of x are x equals to 3 or x equals to half, 1 by 2. Now the next question, 2x square plus x plus 4 equals to 0. Here the coefficient of x square a is equals to 2, coefficient of x b equals to 1 and the constant term is 4. So let's find the discriminant, b square minus 4ac. D equals to, in place of b square, 1 square minus 4 into 2 into 4, putting the values of a and c. D equals to 1 ones are 1 minus 4 twos are 8, 8 fours are 32. Plus minus minus, since the bigger number is 32, so the overall sign will be minus. 32 minus 1 will be 31. So D is minus 31. That means we have got a negative quantity for D, which is less than 0. Hence, no real roots exists. In this case, we will have a complex root, so we don't need to proceed further. Moving on to the next question. 4x square minus 4 root 3x plus 3 equals to 0. Here, the coefficient of x square is 4. The coefficient of xb is equals to minus 4 under root 3, and the constant term c is equals to 3. Let's find the discriminant. D equals to b square minus 4ac. D is equals to, in place of b square, minus 4 root 3 square minus 4 into 3, putting the values of a and c. Here, minus 4 under root 3 whole square means the square is for both minus 4 as well as under root 3. So let's write them separately. D equals to minus 4 square under root 3 square minus 4 4 is 16, 16 3 will be 48. So D equals to minus into minus plus 4 4 is 16, root 3 into root 3 will be 3 minus 48. Now D equals to 16 3 is 48 minus 48 will give us D equals to 0. Since the value of discriminant is equals to 0, it means there will be 2 equal roots for the quadratic equation. So we know the special case. Whenever D is equals to 0, in order to find the roots, we can put the formula x equals to minus b by 2a twice, as the roots will be equal. So putting the values, x equals to minus 4 under root 3 by 2 into 4, and we will just write the same thing again. X equals to minus into minus plus, so the sign will change to plus. 4 root 3 by 2 4 is 8. Let's write them again. 4 1s are 4, 4 2s are 8. We'll do the same thing here as well. 4 1s are 4, 4 2s are 8. So the values of x are x equals to under root 3 by 2 and x equals to under root 3 by 2. The roots are equal, as the value of D is equals to 0. The next question, 2x square plus x minus 4 equals to 0. Here the coefficient of x square a is equals to 2, the coefficient of xb is equals to 1, and the constant term c is equals to minus 4. Let's find the discriminant. D equals to b square minus 4ac. Putting the values, D equals to 1 square minus 4 into 2 into minus 4. D equals to 1 1 is 1, minus into minus plus, so the overall sign will be plus. 4 2 is 8, 8 4 is 32 plus 32. So D equals to 1 plus 32, that is D equals to 33, greater than 0. So this suggests we will have 2 distinct real roots for the quadratic equation. Now using the quadratic formula, x equals to minus b plus minus under root d by 2a. Now putting the values, x equals to minus 1 plus minus under root 33 by 2 into 2. Here the quantity that is inside square root is 33, which can be factorized only as 3 into 11. So neither 3 nor 11 will have a pair such that we can take them out of the square root. So that means we will have root over 33 inside the square root itself. We cannot take any factor out of the square root. So x equals to minus 1 plus minus under root 33 by 4. Now since we have a plus minus sign before root 33, so we can write them as 2 different roots like this. X equals to minus 1 plus under root 33 by 4 as one of the roots, or x equals to minus 1 minus under root 33 by 4 as the other root. So we have got two distinct roots for this quadratic equation. Now these are similar questions for your assignment. So try to solve these.